In this video, I will show you how to use scientific notation in my codes. The first code I will be showing you is the force of gravity between two celestial objects. Okay, I'll show you how to use the code in a certain scenario. Scenario 1. What is the gravitational force between the Earth and the Moon? Calculate it when the Moon is at its minimum distance away from the Earth, which is 3.844 times 10 to the 8th meters. The mass of Earth is 5.9722 times 10 to the 24th kilograms, and the mass of the Moon is 7.3477 times 10 to the 22nd kilograms. The radius of the Earth is 6.3781 times 10 to the 6 meters, and the radius of the Moon is 1.7374 times 6 meters. Okay, the first thing we're going to do is calculate how far the center of the Moon is from the center of the Earth. To do that, we have all of the distances that we were given to us, and we get 3.9252 times 10 to the 8th meters. Okay, now I'll start the code. Okay, the first object will be our Earth, which was 5.9722 and times 10 to the power of 24. Second object will be the Moon, which is 7.3477 times 10 to the power of 22. Then our R was 3.9252 times 10 to the power of 8. Okay, so this means the force between the two is 1.9 times 10 to the 20th newtons. Okay, I'll show you scenario 2 now. Okay, calculate the gravitational force between Jimmy and the Earth. Jimmy is 82 kilograms and he is standing on the surface of the Earth. Next, mass of the Earth, 5.9722 times 10 to the 24th. And the mass of Jimmy is 82 kilograms. And since it's just 82, we do times 10 to the power of 0. Okay, then the R would just be the radius of the Earth, which is 6.3781 times 10 to the 6th. And then we get the force between the two is 8.03 times 10 to the 2nd power newtons, or 803 newtons. Okay, now for scenario 3. Okay, for scenario 3, this will use the acceleration code instead of the gravitational code. I'll show you how to use scientific notation when my code doesn't ask for it. Okay, you see a snail at the end of your driveway. Calculate how long it will take the snail to reach you if its initial velocity is 0. Its final velocity is 2.68 times 10 to the negative 4th meters per second, and your driveway is 8 meters long. Okay, so then the velocity final of the snail, so then 2.68, and then for scientific notation you would do e negative 4. Velocity initial was 0, acceleration we don't know, and time we don't know, and then distance was 8 meters. Okay, so this means the time was 59,701.5 seconds, or about 16.5 hours, and the acceleration was 4.489 times 10 to the negative 9th meters per second. And that is how I use scientific notation in my codes. If you have any questions, ask in the comments, and I'll see you in the next video.